Let us solve this given linear system using Gaussian elimination. In short, our goal is to come up with the row echelon forms of the equivalent augmented matrix of this, and with that we can actually show the correct values, or if there are correct values, or the exact values for the unknown variables x sub 1, x sub 2, x sub 3. Let us try to start with coming up with the augmented matrix of this. So our augmented matrix is 2, 2, 2, 0. Next, negative 2, 5, 2, and 1. And we also have 8, 1, 4, and negative 1. So this is the augmented matrix of this given linear system. And let us apply row operations to come up with a row echelon form. So let us try to come up with this operation. Let's try to make the first entry here in the first row a leading 1. And right after that, we're going to make sure that the next entries on the same column would be 0. So let's start with multiplying our first row by 1/2 to have a new row 1. Now we could actually start with this first and before applying the rest other operations, but just to make it this video shorter, we could also try to do this one using the same row 1. Okay, the same row 1, not this row 1 here, but the same row 1. Let's try to add row 1 plus row 2 to be our new row 2, because when we add 2 and negative 2, this will become 0. At the same time, let's also multiply negative 4 to our row 1 and add row 3 to have a new row 3. Again, the row 1s here is not this result here after the multiplying all entries by 1/2, but it's the original row 1 here. But of course, for some of us who find this difficult to understand, we can start with this first, making this probably 1, 1, 1, 0, and then apply all of this. But just for the purpose of this, let me try to inject all of these operations at once. So multiply all entries in row 1 by 1/2, 1, 1, 1, 0. Next, row 1 plus row 2, again, not this row, but the original. So you have 2 plus negative 2 is 0. Then 2 plus 5 is 7. 2 plus 2, 4. 0 plus 1, and then 1. Okay? Next, let's multiply negative 4 to row 1. Negative 4 times 2 is negative 8 plus 8 is 0. So we have achieved this, as this is the requirement, one of the requirements for the row echelon form, or after using the Gaussian elimination. Next, negative 4 times 2 is negative 8 plus 1 is negative 7. Negative 4 times 2 is negative 8 plus 4 is negative 4. Negative 4 times 0 is 0. I still have negative 1 here. Now, let's make this a leading 1. So we multiply all entries of our row 2 by 1/7 to get a new row 2 rather. Again, I'm just going to inject additional row operation here. I'm not going to use the new row 2 after this operation, but the same row 2 here. So we'll add row 2 and row 3 to have a new row 3. So after this becomes 1, this will become 0. It will look like this. So the first row is still 1, 1, 1, 0. The second row, all entries will be multiplied by 1/7. So 0, 1, 4/7, 1/7. And for the third row, we simply add the original row 2 or the previous row 2 to our previous row 3. 0 plus 0, 0. 7 plus negative 7, 0. 4 plus negative 4, 0. 1 plus negative 1, 0. So this is already done. This is our row echelon form, as the last row is all zeros. And by the way, you might notice here that the number of non-zero rows is 2, but there are 3 variables there. In short, we expect a free variable, which will be represented by an arbitrary variable. Because if we are going to come up with equations relating to this, our first row will be x sub 1 plus x sub 2 plus x sub 3 be equal to 0. Our second row would be x sub 2, then plus 4/7 of x sub 3 is equal to 1/7. We don't have an equation for the third row. And again, there are 2 variables here. And we don't know the values of these 2 variables. And that is why one of which, and that would be x sub 3, be represented by an arbitrary variable. In short, for this linear system, there are infinitely many solutions. So if this is our x sub 3, this equation, x sub 2 plus 4/7 of x sub 3, that's t, is equal to 1/7. X sub 2 now is equal to 1/7 minus 4/7 t. So this is now your x sub 2 using the arbitrary variable t. And for our first equation, it will be x sub 1 plus x sub 2, which is 1/7 minus 4/7 of t, plus your x sub 3, which is t, is equal to 0. So you will have x sub 1 is equal to, subtract both sides with 1/7, so you have negative 1/7. And the result of this is positive 3/7, but we are going to subtract it on both sides. We'll have minus 3/7 of t. So this is the result of x sub 1. So we have solved this linear system, but again, we use arbitrary variable t to represent the values of x sub 1, x sub 2, x sub 3, for there are infinitely many solutions. But these were made possible by our Gaussian elimination, or this final row echelon form. Thank you for watching.